Okay, starting chapter 11 today, 11.1, stem and leaf plots and histograms. Here's your vocab that you guys just got done writing. Stem and leaf, show of hands. How many of you remember those from last year? Excellent, good. You use that to organize data based on, the main important thing here is the digits. We're working with the digits. The tens, the ones, the hundreds. Then we're going to learn how to do frequencies using tally marks, making a frequency table. And then with a frequency table, that's what you need to have in order to make a histogram. You cannot make a histogram without a frequency table. And that's what your homework will be today, making stem and leaf plots, frequency tables, and with that frequency table, we'll make histograms. All right, first part. Practice making a stem and leaf plot. Here in this little example number 1, the amounts are in pounds. All right, so we're talking 449 pounds, 450 pounds. That's of hay eaten by 16 elephants in one day. They're all listed here in this little pile of mess. Now, there's 16 different numbers because there's 16 different elephants. Now, if we look at the data, the least data value is what? What's our smallest number?
390.
The smallest one is, what are you saying?
390.
Right there. What's our biggest one? 479. Okay, so 3. Good, there is 2 of them. The smallest one is 390. The greatest one is 479. So we are going to let the stems be the hundreds and the tens digits, and then we will let the, how do I say leaf, plural?
Leaves.
Leaves. We will let the leaves be the ones digit. And this is usually what you guys get stuck on, is like, which one is my stems and which ones are my leaves? Well, it's easy. But today I'm going to have you do all of your stem and leaf only. I'm going to give you graph paper that looks like the background here. And that way it'll help you figure out which are which. You know, which ones are my stems, which ones are my leaves. First thing you need to do is find, like we just did, we need to find the smallest number and the biggest number. And so if I write that on my graph paper and each digit gets its own box, we got 390, and then my largest one is 479. 479. Now I need to write, and I wish they would have done this for you. They already did them for you. I wish you would have had to write them yourself. They're just too nice to you. But say this isn't here and we have to write our stems like you do on your homework today. You write your smallest one up here, your largest one down here. And then, you know by looking at that, now that we have them all lined up, the last, then what you do is you go like this. The last digit here, the ones, that is your leaf column. What column is this then?
Stems.
These are our stems. But now this is just the beginning, because my stems are 39 and 47. That means that's my first one. This is my last one. Just like they did it over here. 39 is your first one. 47 is your last one. So then you go and you fill in your stem and leaf plot. On your paper, you have to make this T graph just like this. All right? And you'll label it stem and leaf. And then you'll start with the first one is 39. You go 39, 40, 41, 42, 43. How far do I have to go?
47.
44, 45, 46, and 47. That's what it'll look like on your paper. They have it like this. And they don't have them labeled, which we need to add, stem and leaf. All right, so now we've got our stem and leaf chart set up. Now we have to add the leaves. So we go back to our data. Right up here, this whole mumbled jumbled. It's hard to tell how many of each. What's the smallest, what's the big one, you know, if there's a lot at the top, a lot at the bottom. By putting them in a stem and leaf, we can figure this out and make more sense of it. So then we add our leaves. Let's do this, all right? Just make sure you don't forget any, otherwise that throws all your data off and it's not correct. So I like to cross them off as I go. So behind the 44, I put a 9. Okay, so I find my 44, and I put a 9 there. All right, you're over here, you'll put a 9 here behind your 44. That one's done. Now here I put the very last digit, I put the 0 behind a what? Behind the 45. So I find my 45, I put a 0, because that tells me I have a 450. All right, cross that one off. Behind the 41, I put a what? Good. That one's done. Put an 8 behind the
44.
Good. Put a 9 behind the
47.
Good. Put a 0 behind the
41.
Put a 6 behind the
44.
Put a 5 behind the
46.
Yep. Put a 5 behind the That one's done. Put a 5 behind the Good, behind the 45. Put a 9 behind the Now do I have to put this 9 here also? There's already a 9 there.
Yeah.
Yes, you do, because that number shows up twice. One elephant ate 479 pounds, so did another elephant. They're the fatties at the bottom. They're the big eaters, okay? So, done with that one. Cross it off. Put a 0 now behind the 39, right? Put a 3 behind the Good. Put a 3 behind the Excellent. Put a 0 behind the Yep. And the last one, put a 9 behind the Now, notice I don't have anything behind the 42 here or the 43. Notice that?
Yes.
So do I need to include those in my stems? Yes.
Oh.
Yep, you do. Even though there's nothing in there, it shows us that there's that gap, and it just shows us that there's nothing there. So you just leave them blank, and they need to be in there. Now notice this is labeled unordered plot. Your final one on your homework then have to be in order. So over here, add what they forgot to add, stem, leaf. And let's put them in order. Behind the 39 then, do I have to change anything?
No.
Nope, they're already in order. 40?
No.
Nope. 41?
Yeah.
Yep.
0, 5, 9. We want them in order, so we know there's 410 pounds, 415, and 419. 42, 43, nothing. Behind the 44, we go 6, 8, 9. And notice, do I need commas in here? No. Not with stem and leaf. We do not use any commas to separate. Behind the 45, 0, 5. The 46, I got to switch those around to 0, 5, so they're in order. And then the 47, a 9, and a 9. Now my stem and leaf is almost complete. Question?
Why are there no commas separated?
That's a good question. We don't need commas because we know that each digit stands for one number. So we know that only one number belongs to this. So I don't have to separate them. So it's not going to be like 3,903.
Will there ever be like 4?
Nope. Over here, yeah, your stems can be longer than this.
But only one in the leaf?
Yep, but your leaf can only be, so this goes with this one, this goes with this one. You can't have two numbers as a leaf. It's the very last number, the very last digit that is your leaf.
On the 40 is supposed to be 39. It's not 400, it's 400.
Where'd I goof?
No, 400, it's 400.
This one's a 3?
Yeah.
Oh.
0 is 0.
Oh, the 0's a 3?
Yeah, yeah.
Oh, thank you. That one's supposed to be a 3?
Yeah.
Good catch. Right here?
Yeah.
So I have a 3
And a
3,
9.
9.
and a 9. There we go. Thank you. Question.
Oh, besides the elephants, what would this be used for in real life, and what did this determine?
Like if say you're keeping data on, maybe you have a horse farm and you want to know how much feed they eat or whatever. Maybe there's different types of fish that you want to feed. What kind of fish eat the most food? Maybe you're working in a factory and you want to see which machinery takes the most energy. So you have all these different energy bills from different days and different months. You could break down the data.
But there's a whole bunch of random numbers in there, so how do you determine what it's going to do?
Well, now when we look at this, because now we're almost done. Let me explain that, because let's do the one last thing to finish this. What do we have to do to finish this? Drew?
Title. No, I was just wondering.
Oh, okay. So down here, see this? Don't forget your key, so you don't lose your points for the key. When you make a key, what do? A lot of people will take this very first one, the 39 and the 0, and they'll go, you have to write key with a colon, then you write 39, like they have here, then you have your line to separate it right here like we have our line, and then the first number behind it, a 0. Well, what does that mean? Does that mean 390 million? Do I have to write 39, 0000000? Or does it just mean 390? Just means 390 in this case. So that's what we do. Sometimes you might have decimals. Maybe these were 39. All these numbers had decimals. Maybe they're 44.9, 41 point. See what I'm saying? Well, you wouldn't put your decimals in here either, unless your decimal was somewhere over here in your stem. And that's kind of a controversy too. Some people say you don't even need the decimal over here because you show it in your key. So it can be done either way. So you always have to have your key. All right, now, question? Did we answer all the questions? I can't remember. We're good? So by looking at this stem and leaf, what can we come up with talking about the stem and leaf? What do we see from it? The elephants and the amount of pounds of hay that they eat. Can you tell anything?
No.
Majority, half of them are doing this, half of them doing that. What's that?
A lot of them, most of them eat a lot.
Majority of them are, what, up in this area?
Yeah.
We have 1, 2, 3, 4, 5, 6, 7, 8, 9 of the elephants out of the 16 are in the upper half of the eating. Maybe that would tell us, did they say what size the elephants are?
No.
So maybe we could take a guess that maybe these are the what? Maybe those are the babies or the smaller elephants. Maybe the bigger elephants are eating this many. You don't know. We could go with that if they're keeping track. All right, but majority of them are towards the top end of them. There's nobody really in the middle. It's kind of like either they eat a lot and they're fatties, or pretty good sized elephants, or they're just a little dainty, not too hungry. All right. Cross that out because we kind of went over that already. All right, so that was stem and leaf. Now, before we go on to this, I want to show you one more thing that you'll see on your stem and leaf. Say we have the numbers, you have all these numbers and you have to make a stem and leaf plot, and the smallest number that you have is an 8. Come on, pen. There we go. The smallest number you have is an 8. Only yours will be in a graph number. There we go. And let's say our largest number is 53. All right? Where do I draw my line then? Say it again. What did you say? Right here? Exactly. That's where we would go for our stem and leaves. This would be, oops. Alright, so like we were saying, if you have the smallest number you have is an 8, the biggest number in your data set is 53. Now if we're going to make our stem and our leaf, our stems and our leaf out of that, because you told me to draw the numbers between the 5 and the 3 and the 8. Well, what happens here? I don't have a stem for the 8. What would it be?
0.
Nice. It will be a 0. Okay, so we have to go from, on our stems, we have to go from, what?
0.
0,
0.
1,
Yep. A 1.
2, 3, 4, 5.
5. Okay, so that's what we would go through. So now if I had the number 5, where would that go? The 5 would go where? If I had just the plain old number 5, where would I put that in my...
After the 10.
Right. What if I have the number 17? Where would that, what would I put where?
1. 7 after 1.
The 7 after the 1. What if I had 42?
2 after the 4.
Nice. What if I had 10?
1 and
0 after 1.
0 after
If I had the number
One.
10, what do I put where?
0 after the 1.
The 0 behind the 1. So here's the 1, I put a 0 back here, alright? So then we would have to just reorder them so they're in order from least to greatest. Does that make sense? Alright. Now let's go on to the frequency table. And we will be using this frequency table on the histogram on your next example. Let's go green. Here we have ticket prices. The average ticket prices, these are rounded to the nearest dollar, that are charged by Major League Baseball teams in a recent year are listed below. Make a frequency table of the data. Yeah, don't you wish tickets were that cheap? I don't think you can get into many ball games, Major League ball games at that cheap. I wish.
$8.
Must be an old problem. We could update that, but anywho, here we go. So we are looking at what we need to do. It says choose intervals of equal size for each data. Well, right here, they did it for you. What do they go by? Each interval goes by how many? 2?
Yeah.
No. 8 to 10 includes how many ticket prices? The dollar number 8,
They put
9,
1,
and 10.
3.
How many different numbers is that?
3.
That goes by an interval of 3. So hopefully this one does too. 11, 12, 13. That's by 3. 14, 15, 16. Thank goodness. And I know for a fact they all go by 3. Can I have some go by 3 and then go by a 2 in here and then a 5?
No.
No. Your intervals all have to have the same number. Alright? So we know they all go by intervals of 3. And what you do, the way to do that, is you take your range. What's the smallest number we have here?
8.
8? What's my biggest number?
24.
So $8 is my smallest, and what's my biggest?
24.
4.
24?
Yeah.
So you would take 24 minus 8 and get what?
16.
16. Now, if you look ahead, if we peek, how many intervals do we have here? 1, 2, 3, 4, 5, 6. So if you divided that by 6, 16 divided by 6 is what?
2.6.
2.6 repeating, round that to the nearest whole number?
3.
3. So that's how they came up with 3 numbers for their intervals, because they wanted 6 bars to show. Would you want to make a histogram with just 2 bars?
No.
That's boring. That won't tell you much.
Will there ever be where the intervals aren't the same language?
What do you mean? If they're like 3, 3, 3, 3?
No, like if they're just not the same.
Like they're not the same.
3, 4, 3. 2.
Oh, you can't. That would be an invalid.
So I can't have it.
Nope. They can all be 5s. They can all go by 10s. Sometimes if the data numbers are big, you can go by thousands or hundreds or whatever. But each one would have to go by 1,000, and then and so on. But they all have to be the same. If you have one that's different, it would be counted wrong, invalid. All right. So that's how they came up with 3. Now notice they actually started theirs with their smallest number 8. Would you need to?
No.
No, you could have started with 5 and gone up, just as long as your smallest number is included in here somewhere. Because their biggest number is 24. Well, when they went by intervals of 3, you're not going to land on exactly 24 when they started on 8. But 24 comes right in here, so they're covered. They're good. All right, now, who's done tallies before? Good. What happens when I'm doing tallies and I get 1, I get 1, 2, 3, 4 tallies. What do I do with my 5th tally?
Cross.
Yes. And why do you suppose we do it like that?
No.
Count by fives.
No, the fives.
Yes. Yep, absolutely. Because it's easier to count, because you can count by 5s that way. All right, so you guys, let's do our tally marks. Don't leave out any numbers or your whole table will be invalid. So 23, where do I put a tally mark? What do I do?
23.
This is 23 through 25, so 23 falls in this one, so we write a tally mark. Cross it up. 24, another one there. 20. 19. 20. 20 again. All right, you guys fill in all your tally marks, count up your tally marks, and fill in your frequency number right here and see if it matches mine when I get done. Do yours match mine? 4, 9, 5, 7, 3, 2. Did I do all right? I didn't miss any?
Yeah.
If I add these all up, how many numbers do I have total?
A lot.
How many different parts were tallied? What do we get? 30, right? So if we didn't get 30, something was wrong, because when I counted these earlier, there were 30 numbers, so they match. I did not forget any. All right, now let's take this and go make our histogram. Now mine's already done for you on mine, but you have to do yours. But let's fill in this first. It says show the intervals from the frequency table on the what? The x or the y-axis? What did we talk about? That is on the x-axis, right down here. See the intervals? We have 8 through 10, 11 through 13. And now say this wasn't a word problem, you always have to label it. So if this wasn't a word problem, what would I label it? Nope, if it's not a word problem. Intervals. Your intervals are always on the bottom, your x-axis. What if there wasn't a word problem, we didn't know it was number of teams then? What do you suppose is going to go here? And show the what on the y-axis? The what?
Frequencies.
Yep. So we would label this frequencies. If it was just a problem and not a word problem, they just give you numbers. And then this is Major League Baseball ticket prices. That has a title, which you always have to have. Well, what if yours doesn't have a title? What are you going to title it? We've got intervals, frequencies, and maybe it's number 7 in your homework. That would be its title, whatever the number is on your homework. Make sense?
Yeah.
All right. Now you have to draw a bar to represent the what for each interval. Yep, for each frequency. So therefore, when we look back, how many are 8 through 10? 4. So you draw a bar from 8 through 10 up to the 4, and then you fill it in. 11 through 13, we had 9. Now notice on my bar graph, there are no gaps, no spaces between my bars. You don't leave spaces on your bar graph. The only time you would have a space, like if this were to be gone, why would I have a space in here?
There's 0.
Right, absolutely, it would be 0. It means they wouldn't have any. But in this case, we don't have any spaces. They're all right next to each other. So fill in your bar graph so it looks like this. And then we have the final problem here of the day asking us from the histogram about what percent of the teams charge $20 or more per ticket. How many do you think are $20 or more?
5.
5.
5? How do you get that?
30 divided by 5. Means 6.
Plus 2.
3 plus 2? Because $20, here's 20 or more, so it's going to include this one right here and this one right here. What are those two added together? 3 and 2 is 5. So is it 5% then?
No.
No. It's 5 out of how many?
30.
30 total teams. Divide that on your calculator, you get,
6, 8.
what do you get? 0.1666, right? And so on, you keep repeating. Then I take it times 100, boing, boing, that moves your decimal twice. So rounded to the nearest percent, go at 16 or 17%.
17.
So about 17% of the teams charge what?
$20 or more.
$20 or more. Questions?
Oh, I forgot a percentile.